Thank you. Any other announcements? All right. Now, I want to briefly introduce Chris with Ross Controls. I had an opportunity to spend some time with him last week. Got to know him pretty well, or actually got reunited with him. We've known each other for a lot of years. I'm gonna let you introduce yourself once you get started, but I want to tell you just a little funny story about this guy. He brought COVID to the United States. He is personally responsible for this pandemic, and he may not take credit for it, but I'm giving him credit for it because he had it long before the rest of us did. But at any rate, if you would share with us and introduce yourself, and then we'll look forward to talking here in the end as well.
Well, you may have to unmute me. Can you guys hear me okay?
We're good, yeah.
All right. Well, since he's told the story, I mean, I've got to tell the rest of the story, like Paul Harvey says. And for you younger people, you may not even know who Paul Harvey is, so Google it. It's pretty funny. I was actually in the car with Paul, like he said, last week down in Texas, and we got to talking about COVID and the effects that we've all seen, you know, with not being able to visit and see each other, families and everything. And, you know, back in 2019, in October of 2019, I was in Wuhan, China, and right where this whole thing came from, right across the street from where their chemical warfare and chemical labs are right there. And so I came home sick with that, and had all kinds of tests done at the hospital. They couldn't confirm what I had. It was not strep, it was not flu, it wasn't anything they tested for. Then my wife got it, my grandson got it, my daughter-in-law got it, my son got it. And then fast forward into 2020, I was back on another Asia trip, came home and through Canada, was in Canada, got home 2 days before they closed the borders. And then this whole thing about COVID came up. And then on up into May, when they started doing the antibody testing, all of us tested positive for antibodies. So, you know, I believe I had it back in October 2019. And so it was around long before any of us knew about it. It's what I'm getting at. And, you know, so thanks for sharing that, Paul. I wouldn't expect any less of you. So it is just hearing you talk about having 14 new people coming on. It's really encouraging to see, especially you young people starting to take part in safety. It's an important thing. And I've sat on standards committees for over 20 years. I've been associated with the ASSP before it was called the ASSP in Kentucky, and then in Michigan where Ross is headquartered. And I will tell you this, all of us people sitting on a lot of the standards, we're getting older. When I look around the room, it's a lot of gray-headed people. We need you young people coming in, not only to, you know, this ASSP, but also getting involved in standards, getting involved in committees is where we make a difference and where our voice can be heard. So I encourage you, as you're on your journey in safety, look at getting into committees, like some of the ANSI subcommittees. Kind of at Ross, you know, we're a fluid power safety company, been around about 100 years, and we have 3 or 4 of us that sit on standards. And Eric Cummings, and I don't know if Eric was able to join, but Eric is on the road today. But Eric sits on most of the ANSI committees, and I sit on a lot of the ISO and IEC committees. And I will tell you this: the changes in industry are being influenced from around the world. It's not just ANSI anymore. You're starting to see, you know, ISO standards, IEC standards. And what I'm getting at is there's a lot of global harmonization occurring. When you read a lot of the international standards, it's just like reading the ISO standards. A lot of the verbiage is exactly the same. And so, you know, I encourage you young people, get involved in these standards if you can. And if your companies will support it, you can have a voice and you can make a difference in what happens, you know, here at your facilities. And so with that said, Paul asked me at the AIST meeting, which is a steel conference that we were at, safety committee meeting, if I could present. And I said, yeah, I've got something that I'll just throw out. So this may not be exactly the format and everything that you guys normally use, but I told him I had one on lockout. And there's a lot of questions around lockout today, and a lot of companies have a lot of confusion around it. And so I put together a very brief presentation, hopefully to start some discussions. And we do sit on several of the committees related to lockout, both nationally and internationally. And so we'd be happy to answer any questions you've got, or facilitate some collaboration further even after this meeting. So with that said, I'm going to share my screen if that's okay with you guys.
Absolutely.
All right, you let me know when you can see the screen.
We're good here.
All right. So what I put together, and I actually stole your logo off of an email that Paul had sent me, and put it right in here next to Ross, because Ross does speak at quite a few of ASME conferences, ASSP conferences, and various other events like the Steel Technologies event and everything. But we do a lot of speaking. We've been around for 100 years, so we're not a new company. And it was a privilege to be asked, to do this. And if you guys ever want or need to talk about any areas of safety, whether it's related to electrical safety, pneumatic, or hydraulic, we do have expertise in those areas, and we're able to fill in if you have some gaps in your schedule. So just happy we could help you guys out. And kind of what we're going to talk about is the lockout tagout requirements, and some of the best practices that we're seeing, and some of these exclusions and some options that are out here, and talk about this thing called the OSHA RFI that went out a year or so ago about lockout. And then since I was asked to speak, I got to put a couple of commercial slides in here, so I apologize in advance for those, but it kind of highlights some of the solutions that are out there. And then I'd like to have some open discussions. But if you have a question, when I go through any of these slides, feel free to speak up. And if that's okay with you guys, we'll go ahead and get rolling here.
Yes, sir.
Well, as you guys know, the requirements from lockout tagout come out of this little document called CFR 29. So it's Code of Federal Regulations, Part 29. And when you start looking at it, Part 1910-147 really is that is lockout. And if so, a lot of people don't know where that requirement came from. That's where it comes from. And basically what it does and what it says is it addresses the practices and procedures that are necessary to disable machinery or equipment, which prevents the release of hazardous energy while performing service and maintenance activities. And one thing that I do want to hit here, notice what I underlined at the bottom. The standard outlines the measures for controlling hazardous energies. A lot of people think just shutting off the disconnect at the electrical control panel does it. There are other energy sources that you have to consider, like mechanical, like hydraulic, pneumatic, chemical, thermal, and others. It's not just electrical. And something that I see when I go around and tour facilities is I see companies do address electrical lockout and many times ignore other forms like fluids, like pneumatic, hydraulic, and especially around the areas of thermal. Thermal is one area that almost no one really addresses. And, if you look at some of the industries that you guys have there in Alabama, steel industry, you got a lot of hot metal there. So you got to think about all aspects. And when you look at lockout, you have to start thinking about what is involved in servicing, what is maintenance. And so what I tell people, doing an effective risk assessment and having what I call task-based analysis as part of it. What falls into the service, what falls into maintenance, and what falls into this category that I'll mention in a few minutes called routine, repetitive, and integral. So a lot of companies don't spend any time on that task-based analysis and don't have that as part of their assessment, and they really should. And subpart J is for lockout, and it basically covers the essential performance requirements pertaining to hazardous energy control during service and maintenance of machines. And it's really meant to protect against unexpected energization or startup of mechanical systems or of stored energy. So it's not just, stored energy can be in the effects of liquids. It can be electrostatic charge. It could be pressure related to pneumatics or hydraulics. So we got to look at this kind of holistically. And this is right out of the requirements, right out of CFR 29. And there's a link here to www.osha.gov to get to that. And the part that I really want to hit on, and I see gaps when I go to especially smaller organizations, is that U.S. employers have responsibilities. They have to create a program. They have to establish procedures that foster a safe work environment. This is a responsibility of the employer. And in the case of lockout compliance, the program must include procedures for the attachment of suitable lockout or tagout apparatus. A lot of people group lockout and tagout together. They're actually two independent things that can be used together. And what I mean by that, if a device is not capable of receiving a lock, that's where you use tagout. So for example, you may have a handle that is the isolating source, or a valve that is an isolating source but does not have the ability to put a lock on it. That's where you put a tag on it. Many times though, lockout and tagout are used together. When there's a lockable device, you should also put a tag on it for identification. So keep in mind, those are two different things, but many times they're used together. And in addition, OSHA requires employee education. So you're supposed to be doing at least annual is minimal. I know a lot of companies that do quarterly lockout or semi-annual lockout. And the reason they're doing that is because they have a lot of changes to equipment or a lot of employee turnover. And so they're doing more regular lockout classes. And also employers have to make sure that the affected personnel know what they're doing, how to do it, and not only how to do isolation, but how to turn it back on. And so employers are also have to do periodic inspection of the program and the procedures. And the reason for that, and this is a big thing I see a lot of people miss, because machines sometimes get modified over time. And if someone hasn't audited the procedure, they could be ignoring a potential hazard that's been added to the machine since the machine's been modified. So kind of in my bullets here at the bottom, the employer must identify when lockout tagout is necessary. They must identify the energy sources that need to be locked out and tagged out, or locked out and tagged out together. They need to provide the necessary procedures. They need to provide the necessary hardware. And they also need to provide training, not only to the employees, but also to contractors. And I will say this, there's a lot of companies that have great contractor training programs, but I'll tell you this, a lot of smaller companies don't even touch on this. This is a huge miss when it comes to lockout, and it is a requirement. And then employers also must complete those periodic inspections of the programs, the procedures, and the hardware. And the reason I mentioned the hardware, I was at a plant the other day that had a nice lockout tagout board, said lockout tagout on it. It had their book there with their procedures in it, and every one of the locks was missing. There were no locks there to do lockout with. And so you got to maintain your program. And so these are US requirements. Some of the national and international standards go a little bit further. And so I'm going to touch on those just for a little in a couple of slides, because I'll be honest, people outside the US have a leg up on us. And that's why this thing called the RFI went out. And I'll explain that in a couple of minutes. Any questions so far or comments so far? Okay. And if we look at the Canadian standard, and I have missed a slide, give me just 2 seconds. What happened here? Okay. So in Canada, they have a standard called CSA Z460, and they have very specifics about the hardware. And so it talks about being uniquely identified, and it has to be the only device used for controlling hazardous energy, can't be used for other purposes, must withstand the environment. And then another piece, be standardized within the facility in at least one of the following criteria: in color, in shape, in size, or specific markings, or how you label it. And so they identify that having things done consistently within the facility is an important thing. And so the ISO and IEC international standards state this, and it goes above and beyond what the requirements are in the US. But to me, this is a great best practice, because once you know what it is, it's easy to look at additional machines in the instance of an emergency, because it's got a standardized color, shape, or size. And so this is a best practice that I think goes above and beyond what our requirements are here in the US. To take it a step further, they say it's only capable of being locked in the off position, and it's got to be a simple push-pull action, not a twist, not a rotate, a simple push-pull. And it has to have an exhaust port equal to or greater than the supply port. And here's the big piece: shall have a pressure indicator. So not just that you turned it off, it was the pressure actually dissipated, a way to verify that pressure's been gone. So they take it quite a few steps further. So, ANSI B11.0 does have some statements very similar, but Canada also has those. And then one I want to hit on, in Europe, they call it energy isolation, and their standards ISO 14118. But you'll notice the terms are exactly the same: preventing unexpected startup. It applies to all types of energy sources, which includes electrical, hydraulic, pneumatic, energy due to gravity, compressed springs, and external influences. So a lot of the verbiage is similar. And in that standard, it says isolating, disconnecting, and separating all power supplies. And if necessary, for larger machines, there needs to be means of isolating the units or locking those units. And there has to be a verifying means. And I just hit the high ones that I've got kind of circled there. You'll notice that's very common to what the Canadian standard says, and verbiage you'll see in ANSI B11.0 as well. And so with these requirements, I put together a couple of simple slides. One that hits the US requirements. It says that it's got to be manually operated, not used for any other function, easily identified, easily operated. And here's one that most people have missed. It says that they have to be tamper resistant. And here's something I challenge people on, because I go to plants every day and see ball valves. Here's where the problem comes in. Your ball valves are shipped most of the time in a box with the handle off of them, and you have to assemble them when you get them in. So since it does have a nut on it that can be removed, that's not tamper resistant. So you have to be very careful in what you're implementing as your lockout device. And just for Ross, the products on the right are our lockout devices. And you can see it is very unique in appearance. It does have a pressure indicating means, lockable only in an off position, and a simple push-pull action. And so there's a lot of devices very similar to ours out here. I would encourage you to look at that, because tamper resistance is one of those things that most people have not looked at in their facility. And then the international standards, like the Canadian standard, the ISO standard, they go a step further, and that's where they say distinct from other manual valves. So if you look at this in the top right here, where you've got ball valves, you either have to tag, if your main valve is going to be a lockout, it's got to be tagged properly. so it's easily identified, or the valves got to be distinct from those other manual valves. And then also a requirement from the international, as I mentioned earlier, is full diameter exhaust. Most of your ball valves only have a 2 or 3 millimeter hole on the back of the ball valve. And here's where problems come in, is if, especially in the instance of a large machine with very large pipe sizes, to be able to dissipate air through a small hole like that, it's going to take quite a bit of time. And if someone is trapped, that's time that you waste in getting them out of the machine, waiting for that energy to dissipate. A lot of your better lockout companies, like the Ross valve here, usually has, it's at least the same size as a supply port or bigger. So it's very quick dissipation of energy. And the other thing, lockable only in off position. There are valves that can be locked on or off. You have to be careful in utilizing those. And then the big one, a method for the employee to verify that the energy has been dissipated. So it could be a downstream gauge, it could be a gauge on the product, a pop-up indicator like this. But the reason I mention these is because a lot of your companies there in Alabama are multinational. If I look at, Honda right there is, a multinational company. And, I did a lot of training with Honda, and they actually updated their lockout standard to meet international requirements because they are an international organization. So this is something maybe you want to look at and at least think about. Any questions there before I get on into the circuit? Well, let me hit the circuit one first. So what I tell people is that lockout valve should be one of the first things you see, because if you're going to service and do maintenance on any of the components in that system, well, you have to be able to isolate energy. That's where your lockout valve should go, would be at the supply power, whether that's air or whether it's hydraulics, whether it's water, whether it's even gases. It's got to be at the source of supply so that you can service all downstream devices. And so that's what I tell people. They should go on a supply line. They should go before any other power control devices, and that they are used for the control of hazardous energy during machine servicing and repairs in order to protect maintenance and service personnel. So just keep in mind, that should be one of the first things you see in a machine. And this is a good example of that from a machine. Actually, this was from Honda. And so that's a good practice. It's right on that incoming line. It's before you get to any other devices. Same thing in hydraulics. It should be after that hydraulic pump and before any of your directional control valves, or and the same thing in liquid systems like water and even gases. So any questions there before I get into this thing called automated control?
Good.
Okay. Well, and Paul, since you were at Nucor, you're probably pretty familiar with the Nucor variants for automated lockout. There's a lot of people try to minimize the effects of lockout by bringing it into their control system. And there's a lot of lack of knowledge out there of when they can. And if you look at it, lockout tagout is for maintenance, service, and repair. And anything that is considered routine, repetitive, and integral, according to ANSI Z244, can be treated with some sort of alternative solution. And a lot of times what happens is people try to use alternative solutions instead of lockout for some of these servicing activities. You have to be really, really careful with that and make sure that it meets those requirements for routine, repetitive, and integral. If it doesn't, you have to talk with OSHA and get a variance. This is much different around the globe. A lot of people allow for the use of automated energy isolation devices. So there's a whole topic that goes around this, and this has been going back and forth since the early 2000s. And if you think about the lockout standard, it has not been updated since 1979. So we are very outdated compared to the rest of the world when it comes to lockout. And so what I just want to touch on it is confusing. I mean, this right here is a clip right off of OSHA's website talking about CFR 29, Part 1910, 147. And it talks about, you know, it is used for maintenance. Well, here's where the conversation changes. There are exclusions for lockout. And the first two are important. The first one is normal production operations are not covered by lockout. And that's just basically, and I'm going to move this. I've got a box here that's in my way. And this is not covered by the lockout tagout standard. That's where your machine safety standards like ANSI B1119 come into play, B1126, which get into, you know, design of your safety systems. And then servicing and maintenance that takes place during normal production operations is covered by the standard only if an employee is required to remove or bypass a guard. And so if that maintenance activity is determined to be what they call minor servicing, which is routine, repetitive, and integral work, that it can be used. So the two places that you can use your machine safety is normal production and minor servicing, and it's only if it is routine, repetitive, and integral to the process. If it is not a routine thing, like if you're, I would say on most machines, replacing a motor is not a routine thing that happens normally during production. That is a truly a maintenance task. That's why I say a lot of companies are spending a lot of time to determine what is a maintenance task and what is not a maintenance task. And what's not a maintenance task, they look at it to see, is it routine, repetitive, and integral, and can it be considered minor servicing? And then they're treating that with machine safety. And so this is a big gap that I see in the industry, and most people don't even look at it this way. Any questions there before I move on? I'll take that as a no. And so in 1998, OSHA made a couple of statements talking about the use of the control system to do some activities. And so, for example, in January 5th of 1988, OSHA did issue a letter of interpretation or a variance for a safety disconnect system that used redundant and monitored control elements like redundant safety contactors or redundant valve assembly to implement an alternative system intended for use even in applications that were not covered by minor servicing. And so OSHA did allow a variance. And basically what they had is when OSHA did their evaluation, they looked to make sure that there were measures that ensured that no motive force to the drive system, meaning there's no ability to generate torque, pressure, or force, and that it provided fail-safe verification, and that the system, in the event of a failure in the system, would default to the safe position or the safe state, and that there is some sort of verification that is provided by the system which actively confirms zero energy state. What they mean by actively confirms, it's continuously monitoring that zero energy state to make sure that it does not come out of that zero energy state. And so basically what they did as part of this is they looked at how the system was made to operate in the event of a failure of any component. And they want to make sure that light, there's no way the verification light that indicates that confirmed energy, there's no way that light can come on. And so this system has to be in a sealed, protected box. And the components that are in that system are certified by a nationally recognized testing lab, or NRTL, and that there has to be an independent lab that did a risk analysis and determined that the system presented the lowest risk to the operator. And so basically the letter concluded this: based on information enclosed, your safety disconnect system has been evaluated as an inherently fail-safe system which performs the same function as energy isolation device. And so because this was termed interpretation, it was widely used in the industry. A lot of people use that letter of interpretation. But then let me show you this. A few years later, in 2003, this gentleman by the name of Richard Fairfax came in and said, for tasks such as major servicing, which is where a traditional lockout is required, use of a remote lockout system would need approval, i.e. a variance letter from OSHA. And so they kind of went back and said, you can't just use that letter of interpretation, you need to get a variance. So there's a lot of confusion around that, because these two, you can still find these statements right on the internet. So with that said, what is happening in the industry? There was a standard that was published in 2008, and it really didn't come out till later, and it dealt with these type of energy isolation systems. And so this standard UL 6420 came out in 2008, and basically what it did is it looked at equipment that is used for system isolation that is rated as a single unit. And so basically what it does is the scope was isolating equipment, incorporating electromechanical controlled devices, things like contactors, things like valves that do the actual isolation. And so it has to be tested as a single unit. And so the UL 6420 puts forth a lot of testing requirements. And so once that system is tested, it's got to be sealed, is one of the statements they use. And so once those systems are built and tested, they have to be sealed, and a signature's got to be placed on those. Now, what has happened is this. In 2012 is when this really came out, and it started talking about these electromechanical, remotely controlled and monitored to provide remote isolation indication with a defined integrity level. So this was updated in 2012, and this is where fluid power has been added. And so with this standard, it provided a lot of clarification, because there was nothing on the market, or no standard for things being used for system isolation as a single unit. And so in conclusion, this OSHA said it can be, traditional lockout as defined by OSHA can be inconvenient and can be slow, especially in large installations with several sources of energy that has to be isolated and dissipated. And correct implementation depends on the training of the employees and those employees following the written procedures. And here's the problem. Sometimes in very complex lockout situations with multiple energy sources, sometimes someone misses a step. And, missing a step can lead to a fatality. And that's basically what they concluded here. And they said that sometimes automated control systems allow that a lockout procedure to be implemented by remote lockout. They exist and are in common use. However, in the US, their use is currently restricted to minor servicing and routine. And they go on to explain that as minor servicing and routine as routine, repetitive, and integral things, unless a variation is obtained. And so people are starting to apply the UL 6420 and using that as part of their justification against a variance that they submit to OSHA. And so what a lot of companies have done is this, and let me step one forward here. Nucor in 2016 was granted a permanent variance to do these remote lockout systems. So what has happened, I know of about 30 companies that went to OSHA, and basically what they did is this, is they documented that they had near misses or issues or even an injury that happened because someone missed the step in a complex lockout process. And they basically showed where that doing a single point or a remote lockout system reduced that risk. And what they did is they used the UL 6420 documentation. They documented their current situation, any misses they'd had, and they quantified how much they thought they could improve their safety program or how much it could eliminate these lockout tasks and the potential for missing a step. And they documented it, gave it to OSHA, worked with OSHA to achieve a variance. So I know more than 30 that have done so. And so with that said, that's a big part of why this whole RFI went out. Any questions so far before I delve into the RFI? Okay, I'll count that as a no and then move on. So OSHA, back in, I guess it was 2019 now, sent out an RFI. And those of you in the safety world may see these. An RFI is basically a request for information. And so what OSHA is looking at here with this particular RFI is two areas around modernizing lockout tagout that might provide better or it might better promote worker safety without an additional burden to the employers. So for example, many regions like Canada, in Europe, their standards allow for the use, and I should have outlined this down in the bottom or underlined it, they allow for the use of machine servicing through energy isolation devices and remote systems. And so that RFI went out and there were over 100 responses that came back from industry. And I know Ross was one of them that sent in some information. So was Rockwell Automation, Siemens, quite a few companies sent in responses and basically urged OSHA to adopt the use of energy isolation devices. There have been discussions around it, but then this little thing called an election happened. And then this little thing called COVID happened. So there hasn't been a lot of progress on adopting something new. It is in discussions, and we hope that at some point OSHA will officially say, yes, that can be used for lockout. But I want to be clear, as it states today, you have to have a variance. And that variance for remote lockout, they're going to look at things like you have to document it. What is your current situation? What is your planned situation? Why are you doing it? What is, how much do you feel you'll be able to improve your system? Is there a quantitative way to estimate what your savings might be as far as reducing potential injuries? And then what is your documented plan for implementing these energy isolation devices? And so a lot of best-in-class companies are really looking at this today. So any questions there before I move on, because I'm just going to hit on a couple of very commercial slides and then we'll be done here. Okay. So this is the only commercial. You got a couple commercial slides here. Ross just happens to be in the area of lockout. We do have fluid power energy isolation devices that go all the way up to a couple of inches in diameter, actually 2.5, 3 inches. And these are just, typical lockout valves, push-pull type valves. They have a full diameter exhaust, lockable only in off position, and they have a means we can either put a gauge here or pop-up indicator that basically says that energy's been dissipated. So it meets the requirements. Recently, we had quite a few customers that hit us up and said, look, we need some help. Our many of our control panels are on mezzanines or they're in control rooms, and people doing lockout may not have access to do those lockouts. So what we provided is basically a product we call e-locks. And basically what it is, it's got a start and stop station. So there's an M12 connector that can integrate into the start and stop circuit of the machine. You can stop the machine. You can rotate this to the off position. And there's a power indicator that shows when you reach 0 volts. And then you can do your simple try to restart the system, the simple test that's required. And so this electrical lockout box, we offer it in a 30, 60, and 100 amp. We also have what we call these remote single point lockout systems that we can isolate electrical, pneumatic, and hydraulic energy from a single lockout point. This happens to be a paper line with multiple lockouts. From any point here, I can lock out all the energy sources from a single point. These electrical, pneumatic, and hydraulic isolation boxes all use redundant, either redundant contactors or redundant valves with voltage meters and pressure gauges to ensure that 0 energy state is met. And that is indicated right there on the lockout station. And so we basically have 2 systems, one called SIS and one called SIS Plus. And basically all that is, one is a single zone system. Everything plugs into the main panel. And you can do 6 energy sources and 26 lockout stations. The big brother to that one is a modular one that's expanded via networks. You can do 30 energy sources, 70 lockout boxes, and 8 zones. So you can get into large systems. And that is all the commercial slides I'm going to have here, but I want to hit on the final details. No matter what you want to call it, they call it energy isolation in Europe. We call it lockout tagout here. Some people call it lotto. No matter what you call it, companies must have a lockout tagout or energy isolation program. It must be documented. Procedures must be created for each piece of equipment. The procedures must be audited. There must be training of personnel and contractors, and every energy source must be controlled. The isolating device has to be lockable only in off position and should indicate that energy has been dissipated. Last statement I'm going to make, and I am done. So Paul, it's all yours, and the floor is open to questions or whatever. I'm going to stop presenting.
Chris?
Yes.
What questions exist? Any thoughts or comments?
Can we get a copy of that?
Yeah, how about that, Chris? Can you share with Justin a copy of this presentation?
Absolutely, I can.
All right, we appreciate you for that. Any other questions? You want to let him know he'll be getting one of the coveted.
Hey, Paul, you're not really clear. I can't hear you well, but I wanted to thank Chris for bringing up on these standards, working with them. And Chris, I don't know if you saw it or not, but Tim Fisher, obviously you work with him, and a lot of us do on the standards. I put his contact information out there. And if there is any emerging professional or anyone interested, contact Tim. He is always open. And I stuck his presentation in the comments there on how important it is to work on these standards. So thank you, Chris, for encouraging our emerging professionals to work on these standards. These are very important, international and within the North American family. So thank you for bringing that up, sir.
Well, we're all getting older, and we need these young people joining, because I will say this: I've been seeing the same people for 20 years with very few.
And remember, Chris, it's not about age. We've got a lot of people that are emerging professionals coming in from, the military, You know, we just talked to one of our new compliance assistant specialists today with a lot of great experience that may be new to the safety field. So guys, if you know someone that's looking for an exciting field, I know ASSP and I know Brad Giles and I both have talked, we need these emerging professionals. Even if you're an experienced person, please come over. It's a great profession, as we all know.
All right, thanks, Don. And Chris, you can see it here in my hand. It's one of the very coveted chapter, Alabama chapter coffee mugs here. So we'll have one with your name on it, and I'll reach out to you to figure out how to get this to you for presenting. We do thank you again.
Well, anytime I can be of assistance, you know, Paul, all you've got to do is call.
I appreciate that. And Donald, thank you again for all that additional information. That was a background on Donald. He wasn't doing yoga in the park.